Scripting basics. In this video, we are going to see about scripting basics. Shell scripts. Theoretically, all shell statements and Unix commands can be executed at the command prompt itself. However, there are times when a group of commands have to be executed frequently, and then it is better to store them in a file and execute them by running the file. For example, to create a shell program that echoes time and date, the shell script can be written as: here, we have created a file called file1.sh using the VI editor. A shell script can have any name. The extension is not mandatory, but if present, it need not necessarily be sh. If the execute permission is set on file1.sh, you can execute it by simply writing the file name at the command prompt as. If the execute permission is not set, then either you can set it to execute using the chmod command or execute file1.sh by using the following command. Shell scripts can take arguments for command link. Shell variables can be assigned values interactively within a shell script. A shell script uses meta characters and control structures like if, loops, etc. Usually, VI editor is used to design a script. Shell commands. Most Unix commands are separate programs run by the shell, but a small set of about 20 shell commands are built-in commands. They use less time than the regular commands. The major examples of internal commands are discussed in detail as follows. The set command. Making scripts interactive, read. The null command : executing commands . The export command. Shifting positional parameters shift. Exit status of a command. The set command. The set is a multi-purpose command. It is used to produce a list of currently defined system shell variables. Secondly, it is used to assign values to positional parameters $1, $2, etc. We'll set $1 equal to file1 and $2 equal to file2. The third use is to set options for the shell. A shell can have options like v, which causes the shell to echo each command before it is executed. The x option is similar to v, except that it also shows the substitutions the shell makes of the variables. The X option acts as a debugging tool for shell scripts. When the shell script behaves indifferently, these options allow you to check what is actually going on in the script. These options can be turned off by using the set and the option letter with a plus sign. Making scripts interactive, read. The read command is used to make a shell script interactive. It can be followed by a single or a list of variable names. The input given through the standard input is read into the specified variables. In read, if more than one variable is given as an argument, the first variable gets the first word, the second gets the second word, and so on. If there are more words than variables, all the leftover words get assigned to the last variable. The null command : it is a null command which does nothing but can be used in setting up an indefinite loop. The : command can have arguments. When this statement is encountered in a script, it implies that a variable ANO is defined. This statement causes a script to halt if ANO is not defined. Executing commands . The dot command runs commands in a file without creating a new shell. It does not allow the use of command line arguments. As the dot command does not create a new subshell, A script executed via a dot command can change the value of a shell variable in the current shell. Suppose you modify the .profile file. Normally, changes made are applicable after you log in again. To put the changes to effect immediately, use the dot command to execute .profile. The export command. The export command can be used in any of the following two ways. It can be used to export the value of a variable to a subshell. The printout of the variables already exported can be obtained by giving export command without arguments. Shifting positional parameters shift. It is used to shift the positional parameters. For example, in the above example, $1 is the pattern and $2 the file name. Suppose instead of one file $2, there were several files, that is $2, $3, $4, $5 and so on. Then we will need to write. But $* will also include $1. To avoid error, we can use the shift command as will produce correct results. Exit status of a command. Every command returns a value after execution. This value is called the exit status or return value of the command. A command is said to be true if it executes successfully and false if it fails. The exit statement is used to prematurely terminate a program. When this statement is encountered in a script, execution is halted and control is returned to the calling program. In most cases, the shell. You can specify an argument that has value with the exit command. This makes a script terminate with a return value which can be used to take decisions. The value of exit is assigned to $? Creating shell scripting. In this video, we are going to see about creating shell scripting. To successfully create a shell script, you have to do three things. Write a script. Give the shell permission to execute it. Put it somewhere the shell can find it. Writing a script. A shell script is a file that contains ASCII text. To create a shell script, you use a text editor. A text editor is a program, like a word processor, that reads and writes ASCII text files. There are many text editors available for your Linux system, both for the command line environment and the GUI environment. Here is a list of some common ones. Now, fire up your text editor and type in your first script as follows. The first line of the script is important. This is a special clue given to the shell indicating what program is used to interpret the script. In this case, it is /bin/bash. Other scripting languages such as Perl, AWK, TCL, TK and Python can also use this mechanism. The second line is a comment. Everything that appears after a / symbol is ignored by bash. As your scripts become bigger and more complicated, comments become vital. They are used by programmers to explain what is going on so that others can figure it out. The last line is the echo command. This command simply prints what it is given on the display. Setting permissions. The next thing we have to do is give the shell permission to execute your script. This is done with the chmod command as follows. The 755 will give you read, write and execute permission. Everybody else will get only read and execute permission. If you want your script to be private, that is, only you can read and execute, use 700 instead. Putting it in your path. At this point, your script will run. Try this. You should see Hello World displayed. If you do not see what directory you really saved your script in, go there and try again. This list of directories is called your path. You can view the list of directories with the following command. This will return a separated list of directories that will be searched if a specific path name is not given when a command is attempted. In our first attempt to execute your new script, we specified a path name, that is / to the file. Most modern Linux distributions encourage a practice in which each user has a specific directory for the programs he or she personally uses. This directory is called bin and is a subdirectory of your home directory. If you do not already have one, create it with the following command. Move your script into your new bin directory and you are all set. Now you just have to type and then your script will run. Generating output. In this video, we are going to see about generating output. The output from a command normally intended for standard output can be easily diverted to a file instead. This capability is known as output redirection. Check following who command which would redirect complete output of the command in user's file. Notice that no output appears at the terminal. This is because the output has been redirected from the default standard output device, that is the terminal, into the specified file. If you would check user's file, then it would have complete content. If a command has its output redirected to a file and the file already contains some data, that data will be lost. Consider this example. You can use double greater than operator to append the output in an existing file as follows. Handling input. In this video, we are going to see about handling input. Just as the output of a command can be redirected to a file, so can the input of a command be redirected from a file. As the greater than character is used for output redirection, the less than character is used to redirect the input of a command. The commands that normally take their input from standard input can have their input redirected from a file in this manner. For example, to count the number of lines in the file users generated above, you can execute the command as follows. Here it produces output 2 lines. You can count the number of lines in the file by redirecting the standard input of the wc command from the file users. Note that there is a difference in the output produced by the two forms of the wc command. In the first case, the name of the file users is listed with a line count. In the second case, it is not. In the first case, the name of the file users is listed with a line count. In the second case, it is not. In the first case, we know that it is reading its input from the file users. In the second case, it only knows that it is reading its input from standard input, so it does not display file name. Exit status. In this video, we are going to see about exit status. If a program finishes successfully, the exit status will be 0. If the exit status is anything other than 0, then the program is failed in some way. It is very important to check the exit status of programs you call in your scripts. It is also important that your scripts return a meaningful exit status when they finish. I once had a Unix system administrator who wrote a script for a production system containing the following 2 lines of code. Why is this such a bad way of doing it? It is not. If nothing goes wrong, the 2 lines change the working directory to the name contained in $sum directory and delete the files in that directory. That's the intended behavior. But what happens if the directory named in $sum directory doesn't exist? In that case, the cd command will fail and the script executes the rm command on the current working directory. The problem with the script was that it did not check the exit status of the cd command before proceeding with the rm command. Checking the exit status. There are several ways you can get and respond to the exit status of a program. First, you can examine the contents of the environment variable will contain the exit status of the last command executed. You can see this work with the following. The true and false commands are programs that do nothing except return an exit status of 0 and 1 respectively. Using them, we can see how the environment variable contains the exit status of the previous program. So, to check the exit status, we could write the script this way. In this version, we examine the exit status of the cd command, and if it is not 0, we print an error message on standard error and terminate the script with an exit status of 1. Using if, we could write it this way. Here we check to see if the cd command is successful. Only then does rm get executed. Otherwise, an error message is output and the program exits with a code of 1, indicating that an error has occurred. Control structure. In this video, we are going to see about control structure. Control structure. Shell supports complete programming features. It has iterative as well as decision statements. The if statement. The if statement allows conditional execution of commands based on whether the given condition I true or false. The if statement can take any of the following general forms. For example, the following if block will remove duplicate files. Shell also supports nested if and conditional operator, that is as in C. Nested if statement. Multi-way branching, if then, elif then else. The if statement also permits multi-way branching. You can evaluate more conditions if the previous condition fails. In the if, then elif, then else, fi form, you can have as many elifs as you want, while the else remains optional. For example, The case statement. When there are a number of alternatives, then you can use the case statement instead of if. The syntax of case differs from that in C. The general form of the case statement is: here, pattern 1, pattern 2, and pattern 3 are labels that identify various choices of action. Generally, the case statement is used to set up menus. For example, the code in the menu.sh file can be used for listing the files, processes, date, or users logged in based on the user's choice. All keywords, whether if, elif, else, fi, case, esac, must come at the beginning of a command, that is, in a new line or after semicolon or ampersand. You can have a choice labeled asterisk that matches any value as last choice to act as a default value for case statement. More than one pattern can be defined in a case label separated by the OR operator 1. For example, you can also use regular expressions as patterns to match. For example, the for loop. The usage of for loop is different in shell scripts as compared to for loops in C language. The variables automatically takes values from the list one by one till the list is exhausted, that is, for loop loops over values in the list. The general form of for is: example, the values of the list can be attained by several methods which are listed below. The values can be explicitly listed as shown in the following example. The values can be obtained from shell script arguments or command line arguments as follows. The file name from a directory can be supplied as a list using shell meta characters as shown below. This will show the contents of each file in the current directory. Values can be taken from a shell variable. Support name is a shell variable containing Smith John Joseph. The values in the list can be generated from the output of a command using command substitution. The backquotes, as discussed earlier, can be used to obtain the output of a command. For example, the loop given above will take names from a file called stud. The while loop. The while statement performs a set of instructions till the control command returns a true exit status. The general form of this command is: the instructions given in between do and done are executed as long as the condition remains true. For example, the following code will search through a list of files and halt at the first file that does not contain the given word. The until loop. The until command is executed repeatedly as long as the condition remains false, that is, the complements the while construct, and terminates when the test condition succeeds. The general syntax of the until loop is as follows. Example: all loops use conditions. These conditions can either be Unix commands with an exit status or a numerical or string comparison that evaluates to false or true. Conditional execution. In this video, we are going to see about conditional execution. A script that uses conditional execution for portability contains an if statement at the beginning that sets several variables indicating the set of commands to use on a particular platform. This section looks at two common cases in which conditional execution is used: determining the remote shell command, determining the proper method of using the echo command in prompts. Executing remote commands. A common use of conditional execution is found in scripts that need to execute commands on remote systems. On most versions of Unix, you can use the RSH, that is, remote shell command, to execute commands on a remote system. Unfortunately, this command is not available on all versions of Unix. On HP UX, for example, RSH is available, but it is not the remote shell program. It is a restricted shell program. On HP UX, you need to use the command remsh to execute commands on a remote system. A script that needs to execute commands on a remote system might have an if statement of the following from at its beginning. After the variable $rcmd is set, remote commands can execute as follows. Here, host is the host name of the remote system and command is the command to execute. Problems with echo command in prompts. Most programs that need to prompt the user need to be able to print a prompt that is not terminating by a new line. There are several problems with using the /c escape sequence of the echo command to do this. The workaround was to use the /bin/echo command. Although this works for Unix versions based on System V, on some BSD-based systems, this does not work. You need to specify the N option to echo instead. By using the following shell script, you can create a shell function echo prompt to display a prompt reliable across all versions of echo. This script fragment uses the /bin/echo workaround as the base from which to construct the correct echo command. It checks the output of an echo command to determine whether the /c sequence is handled correctly. If it is not, the N option is enabled. After the appropriate values have been determined, the function echo prompt is created using these values. This function enables you to reliably output prompts on every system. The test command. In this video, we are going to see about the test command. This command produces no output as such and brings no changes in file. Its sole purpose is to return an exit status of a command. You can perform three kinds of comparisons using the test command: numeric test, file test, string test. Numeric test. The test statement is often used with if as its control command. Numeric comparison in the shell is confined to integer values only. Decimal values are simply truncated. The relational operators also have a different form when used by test. They always begin with a hyphen followed by a two-character word and enclosed on either side by white space. The complete set of operators is given in table. The following examples make use of these operators: Example 1, Example 2, Example 3. Suppose x is equal to 5, y is equal to 7, z is equal to 7.2, then check the values returned in $. after each of the following commands. Here is a shorthand notation for test. You can alternately use $x eq $y hash and must have spaces on their inner sides. File test. The test command has several options for checking the status of a file as shown in table. Example 1, Example 2. T uses the file descriptor instead of file name as argument and returns 1 if the file indicated by the file descriptor is open and a terminal. String test. A string is a series of characters. It could represent a file name, a command name, or value of a variable. Table lists the string handling test. Logical operators A and O, that is OR, and negation of command can also be used for checking more than one condition in the same line. For example, the shell in itself has no computing features. It relies on the expression command. Using positional parameters. In this video, we are going to see about using positional parameters. Shell functions use positional parameters and special variable like asterisk and hash in exactly the same way as shell scripts do. If you wanted to define Alice as a function, you could put the following in your .bash profile or environment file. You will get the same result if you type Alice in Wonderland. Typically, several shell functions are defined within a single shell script. Therefore, each function will need to handle its own arguments, which in turn means that each function needs to keep track of positional parameters separately. Sure enough, each function has its own copies of these variables. That is, even though functions don't run in their own subshells as scripts do, we say that such variables are local to the function. However, other variables defined within functions are not local, they are global, meaning that their values are known throughout the entire shell script. For example, assume that we have a shell script called a script that contains this. If you invoke this script by typing a script arg1 arg2, you will see this output. In other words, the function afunc changes the values of the variables var1 from outside function to in function, and that change is known outside the function, while $1 and $2 have different values in the function and the main script. Notice that $0 doesn't change because the function executes in the environment of the shell script, and $0 takes the name of the script. The below figure shows the scope of each variable graphically. Local variables in functions. A local statement inside a function definition makes the variables that are local to subprogram, units, procedures, function, subroutines, etc. necessary for writing large programs because it helps keep subprograms independent of the main program and of each other. Here is the function from our last example with the variable var1 made local. Now the result of running a script arg1 arg2 is. The figure shows the scope of each variable in our new script. Note that afunc now has its own local copy of var1, although the original var1 would still be used by any other functions that a script invokes. Handling parameters with spaces. In this video, we are going to see about handling parameters with spaces. the simplest form of parameter assignment and expansion. A problem occurs when you want to append extra characters to the end of a variable. Suppose you want to write a short script to process files called 1temp and 2temp. You could try this. But on each loop, you will get the following. What went wrong? The problem is that the shell tried to substitute the value of the variable $itemp, which doesn't exist. The shell doesn't consider this an error. It just substitutes nothing. So no parameters at all were passed to my secret process. To protect the expansion of the $I part of the variable, you need to enclose the I in braces like this. On each loop, the value of I is substituted for $I to give the actual file names. You substitute the value of the parameter into a string. You can perform many parameter substitutions in the shell. Often these provide an elegant solution to many parameter processing problems. The common ones are shown in the following table. These substitutions are often useful when you are working with strings. The last four, which removes parts of strings, are especially useful for processing file names and paths, as the following example shows. Scripting at the command lines. In this video, we are going to see about scripting at the command lines. One of the advantages of working at the shell command line is that you are working in a shell. If you start a loop or conditional such as a while, for, or if or then statement while working at the shell prompt, the command line is just extended until you have finished the steps in the code block. In a traditional script, such code would customarily span several lines in a file. Here is a typical interaction with the shell when entering code directly from the command line. Note that after the first enter is pressed, the command line returns a greater than prompt to continue the code block. You can then keep adding lines until the loop has been completed. Once the last line has been entered, in this case, the done line, the code will begin to run. In out case, it is an infinite loop which can be stopped by a Ctrl+C. The following examples are formatted using more traditional indentation for the sake of readability. If you were to enter these from the command line, you would see results similar to those shown above. Example: this while loop does nothing more than create a long listing of specific files over and over while sleeping for 3 seconds between iterations. It is part of a set of scripts that I use for concurrent package installation on a large number of remote systems. Each concurrent installation produces its own log file which documents its progress and any issues it encounters. All log files are stored in a single directory. I found that while watching the output of the installation loop, I can tell when an installation at a specific node is complete by the size of the log file. This saves me from having to review each log individually. Successful installations all have log files that end up being of a particular size. Files of a different size stand out, shows me that I need to review that log. Also, watching the growth rate of the files can convey information about how the install is progressing. A typical installation goes something like this. The install package is pushed out to the remote nodes. Then, The package is uncompressed on each of the remote systems, where the install script is run until it completes. By watching the file size of a log files increase, it can review the status of all installations at once and generally know at which point they have arrived, as well as note any problems without actually viewing the contents of the log files themselves. This is a representative example of the mini script. Note that I use the IRT switch with IS. This sorts the output by modification time, with the newest files being listed last. This next mini script is nothing more than a series of nested for loops. I have used this type of script to create a large number of empty files in a directory. It is the result of an effort to test a monitor script which is supposed to send notifications in case the number of files in a directory exceeds a certain threshold. In this example, I could have replaced the touch command with something that didn't reference any of the counter variables, that is $i, $j, or $k at all. It could have easily been an echo statement repeating 729 times, but that's just boring. The last example is something I do fairly regular. I often want to gather information from each system named in a list of machines. This shows how to get the list of node names by using a command call within backticks. In this case, the catsum nodalist file would be replaced with an actual list of nodes originally contained in that file. The for loop then iterates through each of the nodes. I have also included an if or then statement which will skip any node named cheese to provide an example that includes a conditional. Shell script debugging. In this video, we are going to see about shell script debugging. In most of the programming languages, debugger tool is available for debugging. A debugger is a tool that can run a program or script that enables you to examine the internals of the script or program as it runs. In the shell scripting, we don't have any debugger tool, but with the help of command line options N, V, and X, we can do the debugging. Disabling the shell, that is N option. The N option, short for no execution, as in no execution, tells the shell to not run the commands. Instead, the shell just checks for syntax errors. This option will not convince the shell to perform any more checks. Instead, the shell just performs the normal syntax check. With an option, the shell doesn't execute your commands, so you have a safe way to test your scripts if they contain syntax error. The following example shows how to use an option. Let us consider a shell script with the name debugcodes.sh. Now run the script with an option. As the above outputs shows that there is a syntax error, double quotes are missing. Displaying the script's commands, that is V option. The V option tells the shell to run in verbose mode. In practice, this means that the shell will echo each command prior to execute the command. This is very useful in that it can often help to find the errors. Let us create a shell script with the name listusers.sh with below contents. Now execute the script with V option. In the above output, script output gets mixed with commands of the scripts, but however, With V option, at least you get a better view of what the shell is doing as it runs your script. Combining the N and V options. We can combine the command line options, that is N and V. This makes a good combination because we can check the syntax of a script while seeing the script output. Let us consider a previously used script debug codes.sh. Tracing script execution, that is X option. The X option, short for Xtrace or execution trace, tells the shell to echo each command after performing the substitution steps. Thus, we can see the values of variables and commands. Often, this option alone will help to diagnose a problem. In most cases, the X option provides the most useful information about a script, but it can lead to a lot of output. The following example show this option in action. In the above output, shell inserted a plus sign in front of the commands.